Webs, that should be working. Fantastic. Let's go to this. And here we go. All right, just me and the microphone. Here we go. Okay, so hello, interwebs. I am here today with Xanadu.ai's Christian Weedbrook, and I'm very, very excited to dive into this because I've been doing a bit of research, and there's some amazing things happening on my doorstep here, like in Toronto, and it's just such a breath of fresh air to be, to have Canada as such an innovator in this, and of course, it takes someone from Australia to make that happen. So, everyone, welcome. I'm going to bring him in now. This is Chris. Here we go. This is Chris Weedbrook from Xanadu AI. Chris, thank you so much for doing this.
No problem. Thanks for having me. I appreciate it.
And we'll find out in the chat in moments now whether I've got the audio right or not. That's usually the first little part of these things is me figuring out the audio. But so yeah, I was so surprised to hear what was happening like around the corner for me, and you were very kind. I had a wonderful time with. Was it Raf? Was it Raf who
Yeah.
took? Oh my God, Raf took me around the offices, showed me what was going on. But maybe you could explain to people what it is that you are, the amazing things that you were up to.
Yeah. Thank you. So quite simply, we're building quantum computers in downtown Toronto.
I love that that's quite simple.
It's quite simple to say.
Yeah.
Actually, doing it is obviously another thing. But building these things in quantum computing, these quantum computers here in Toronto, and what is kind of unique, which you would have seen too, is that we're doing it on in a tower here in downtown Toronto.
Yeah.
So we have two full floors, the 24th floor, and where they're being built is on the 29th floor. So it's kind of wild. We have both full floors, so you can get 360 views of Toronto, which is pretty nice. But you're doing this world class craziness that's going to really change the world. In a tower that's above a supermarket, above Farm Boy.
Yeah, you've got like a dollar store in the basement. Yeah.
Exactly. Actually, so I arrived here in 2010 from Australia via Boston,
Oh yeah.
and I when I first to work at University of Toronto, and I would walk past this building, for 4 years, and if someone told me, that a few years after that there would be a company that I'd be a part of building quantum computers, I wouldn't believe them because it just seems so surreal. So, but fast forward, we were founded in 2016. Fast forward, 8 or more years, we now have 220 people here. We have quantum computers. You saw some of
Oh
them
yeah.
when you came, so they exist now. We're building. They need to get bigger, and that's what our next few years is all about.
How far along were they when you got into this, or are you literally at the beginning of this, the genesis of this stuff?
Yeah, well, there's a couple of things. So myself, along with a lot of people at Xanadu, particularly the early hires, we all came from academia. So we are
Hmm.
contributing through in this field, specifically the field of photonic quantum computing,
Hmm. So
for many
using
years,
light,
using light.
right?
That's
Yeah,
right.
yeah.
Yeah. So an easy way to think about it is using lasers
Right. Yeah.
to
Lasers sound cool
power.
too. Yeah,
They
yeah,
sound cool, yeah.
yeah.
Particularly, we have a bunch of sharks here with lasers on their heads as well.
Isn't that's everyone's goal, isn't it, to get to the point with the moat and the lasers, and the
Yeah,
sharks?
that's it. I've lost any motivation to continue now that we have that.
It's
So
just you're like cats, just playing with the lasers the whole time. It's
exactly. So that's kind of one of the building blocks of what we do here. And so I was part of the field of academia through my PhD and postdoc
Hmm.
times, and so that was going on
Hmm.
independent of the company. But then I started Xanadu in 2016 with the idea of how do we commercialize this research that a lot of us were a part of,
Hmm.
and go beyond the research environment at university, which is a lot of fun. But
Yeah.
now you have the ability to have rather than a small team, you have hundreds of people working together
Yeah.
and on a very specific mission. So it's quite amazing how far we've all come.
You have a wonderful. There's a wonderful interview I saw yesterday that you did where you said quantum computing is really hard, but so's managing people. That you equated these two. That there's a
Yeah,
the
I think
scaling up is difficult for both of them.
it is actually, and there's an old thing. No matter how deep tech or hard your technology is, the most challenging thing is still humans.
Mm,
The interaction of humans is a complex system,
mm,
and so it doesn't mean that it's a bad thing. It just means that you have, you know, when you have more than one person, like, let's say you're in a marriage or in a partnership, that
Mm.
can be challenging.
Mm.
So that's just two people.
Yeah,
You
multiply
need to
that by
see
200 now or whatever it is you've got. Yeah.
exactly. We all have our own set of kind of rule books in our head. We all have things we want to work on. So I think it's challenging, but it's been a bit silly there as well, saying it's the hardest thing. It is hard, but it's not hard on a day-to-day basis.
Right,
Things
right.
come up, we
Yeah.
solve them. But on the other hand, a quantum computer, you're challenging the very kind of microscopic laws of nature on a
Yeah.
daily basis. And you need to kind of get them under control. You need to leverage them to make sure this computer does what you want it to do. So it goes without saying how challenging that would be.
Yeah. It's a wonderful place to visit. I've got to say, there's such a wonderful there's a very it feels very dynamic. There's a lot of people all working on things. They all seem very excited about it. As I say, Raf, who took me around, is just, oh my God, what a gold mine of information. So how did you get into this? Like, how did you? Because I mean, you're literally in a field that just wouldn't have existed, really for people as an option 20 years ago.
Yeah, it's true. A lot of us that when we graduated, it's changed. I graduated from my PhD in '09, and there was really no companies that you could join. And so try to do a postdoc, or for those that still want to do physics, unfortunately they have to go to banking or consulting.
Right, right.
Nothing wrong with those fields, but if you want to continue doing what you're doing in your PhD or postdoc, there's no avenues. So
Mm,
for me personally, my most proudest thing so far is the fact we've been able to employ over 200 people.
yeah.
Having a job and a meaning and a purpose to go to every day is cannot be undervalued,
Mm,
particularly when it gets taken away from you.
right.
So, but my journey really started. I was when I was a teenager,
Yeah.
early teens. I would read books on Rockefeller, Henry Ford.
Oh, really? Oh, so you came at it from the business side.
Oh, for sure,
Really?
and
Okay.
still do to this day.
Yeah.
Reading as much as I can. I just finished reading a book on Massa, two
Ha.
books on him. The SoftBank guy. Reading another one about Andrew Carnegie now.
Ah,
And
so you like reading the manuals.
exactly. It's so funny. I'd rather read these books and kind of absorb stuff than read, say, a manual on entrepreneurship.
Right,
And I think
right.
most people are kind of, like that as well. So I had that as a foundation, and
Mm,
then I tried a few businesses after high school. They didn't work out. They were really nothing, but I was trying different things. Then I went back to university at 23
mm,
because I was okay at math, and I decided to do math. And then physics came up, and then I did a master's and then PhD in physics. But at each point was thinking, man, I wonder if sometime I'd be part of an industry that can commercialize this research.
yeah.
So that's the entrepreneurial thing. So really, the love of deep tech in terms of quantum computing and love of business in terms of entrepreneurship, those two things converged.
Well, and you really need that for something like this too, don't you? Because in that it's an industry that just didn't exist before. What I was very surprised to hear your focus was on batteries. Is that your research into batteries is what you're thinking these? Well, actually, let's step back for a second. This must be the most annoying part about doing what you do is having to explain quantum computing every single time you talk to someone. But in a nutshell, could you let us know what we need to know to talk further about this?
Yeah, it's kind of a magical thing when you think about it, but I try to simplify it so much and say, well, it's still a computer. We're very familiar with computers. But if you can make a computer out of quantum stuff, particles or photons, then you're going to see a new type of computer that can do things much, much faster.
Mm,
So I always give the example that the Xanadu team showed with one of our quantum computers called Borealis. With that computer, we chose a very specific math problem. So not a business problem yet, but something that we knew would be computationally difficult.
mm,
Now, if we had run it on the world's fastest supercomputer at that time, which happened to be in Japan, and used all their 7.3 million GPUs, run it 24 hours a day, 7 days a week, it would have taken 7 million years to get the solution to this problem. So now we're talking, crazy numbers. But our computer, Borealis, that I mentioned, our photonic quantum
mm.
computer, actually solved it in 2 minutes.
It's extraordinary.
So it's hard to really fathom. And so you go from 7 million years down to 2 minutes.
Mm,
So that's really the other example I give and what the expectation is. Things that would traditionally take millions of years
mm,
can now take a couple of minutes. And more importantly, that was an important demonstration and stepping stone to what we're after now is how do you get those speed ups in important areas like drug discovery,
mm.
material design, such as batteries that you mentioned, AI, logistics, and finance. And how do you do the same thing? Now, the counterintuitive thing there is that, well, in all these industries I mentioned, we don't wait 7 million years for drugs.
Yeah.
We still have drugs, but so that alludes to there's two types of problems. One is problems that will take 7 million years, but other
Mm,
problems that would take a couple of years.
mhm.
And so we have drugs, and so it means that we're doing something, and that often starts with computational simulations. They give you candidates that you should try, and then synthesize, and then go through drug discovery trials.
Mm. So
But
before you get to the physical, you're
yeah,
simulating them,
exactly.
and
Yeah,
quantum computing is better at that, more efficient than that. Then
exactly.
I see. Okay,
That's
yeah,
right. So
right,
that's where you'll hopefully see, well, maybe not, you know, well, with drug discovery, it often takes 10 years, $1 to 2 billions on average, and then 90% of the candidates fail.
right,
Now,
yeah,
you could probably get to 100% succeed if you ran those computer simulations for hundreds of years.
right.
But obviously, we don't want to do that because we would never have any drugs.
Mm,
So you need to compromise. You need to say, well, I'm going to accept 90% failure because we need something to work, and you
mm.
still need that 10%. But wouldn't it be marvelous if we had a different computer just in the starting point that could actually flip that and give you 90% success rate?
Mm.
And again, it's because you're working with these systems that are very complex that a quantum computer, we and others believe, are very good at solving. So that's kind of how they all tie together.
I love the image I always get with these things, and it's the only way I can sort of grasp it for myself is that the computers that we're all used to on our desk are solving a maze by trying each different thing, and it takes a long time to try all those different alternatives. Whereas the quantum gets to sort of almost try them all at the same time. So there's this wonderful sort of it's a very effective maze solver. Isn't it? Which is have I got that right? Basically, is that
Yeah, that's right. That's depends who you speak to. There's some hardcore physicists that don't like
yeah? I'm
that
sure.
explanation, but for the most part, that's a good way to look at it. And really, interference is playing a role. So in
Mm,
this maze example, you have things interfering destructively or constructively, like two waves in a pond.
mm,
And the goal is to set up algorithms in this maze example where you can actually work it so you're boosting the probability of the amplitudes interfering constructively and heading towards the right answer. So it is a remarkable thing, and like you said, it leads to, for certain problems, these incredible speed ups.
And are we still at a pure mathematics with this stuff, or is it, or are you sitting there going like, what if? I mean, is there? I mean, how much of it is a sort of a 20,000 foot approach to it, and how much of it is actually in the numbers?
Well, here at Xanadu, it's the whole spectrum of things. So
Oh, right, because you're doing hardware to software, aren't you? You do the whole
yeah,
thing. Yeah,
we're full stack. So we
yeah,
do hardware. We make these photonic quantum
yeah.
computers, and we also build the software on top, which is our software is called Penny Lane.
Yes.
And then on top of that, there's also the algorithm team working at, well, what algorithms should we run on this computer once it
Mm,
gets large enough? So it really depends on where you are. If you look at the hardware, there's a team, for instance, that's building these things,
yeah.
and also a team in hardware called the architecture team that's really pen and paper and simulations working out the mathematics of how
Mm,
to optimize these systems as well. From the algorithm side of things, it's really, what sort of algorithms do we have? How do we apply them to certain problems? Like you mentioned, we're working exclusively on batteries, and
mm,
bigger picture, it's really material design or quantum chemistry.
right.
So yeah, it's what's fascinating here. You have so many different people, over the 220 people that are working at very different levels of the computer in terms of building it. So it's quite incredible.
You've got this wonderful approach too, which I love. This whole modular approach to it, where you get your stable computer, and then you could just keep adding chunks to it until you've got what we need. They're saying, what do you need? Is it 1 million qubits you need before we can start doing sort of truly
That's right.
useful
Yeah.
stuff? Why a
Yeah.
million? Why is it? That's just a numbers game, basically.
It could be, 999,000
Right,
qubits.
right.
So
There's
it
a
could
little
be
leeway. Little leeway. Yeah.
yeah, on average, it's that. And it comes to the fact that, well, the starting point is you want to do an algorithm. You want to do
Mm,
something that can take thousands of years, take it from thousands of years down a few minutes. And so you choose an algorithm. Pen and paper, you assume everything is perfect and it
right.
runs the algorithm and it'll take a certain amount of time. But nothing in life is perfect.
Yeah.
And so you need to add, let's say you have 1,000 qubits that is needed to solve a problem. Well, in reality, you'll need 1,000 times 1,000. So you've got redundancy, and that's where the million comes from.
Hmm.
Uh, Basically, you need error correction and fault tolerance. The computer's not always going to give you the right answer unless you really work on suppressing the errors. And the
Right.
way you do that is by having redundancy, very much like in communication channels. Instead of saying A, I may say A for apple.
Right.
Instead of saying A, you've got the word A, the letter A. Now you've got the word apple, where
Right.
it's like, well, it's not going to be capple, it's not going to be bapple. Like that
Right.
doesn't make sense. So more than likely, you'll understand that it's A for because of the word apple. So you're adding redundancy, and this is where the million comes from. The million is what we call physical qubits.
Hmm.
That's a redundancy, and out of that, you should be able to get around 1,000 good qubits or logical
Really?
qubits, we call it.
Wow.
Yeah. So you need about a million because ultimately you've got some redundancy, and that's also related to how many good qubits you need for the algorithm.
What stage are we at now compared to like the whole PC revolution? Are we still at are we at the Apple kit yet? Am I gonna Can I build one of these?
You kind of can't build it, but you can use them. So
Right.
us and others in the industry have, so people can use it online. So
I
maybe
ran
what's
your Hello World program. I did your
oh, nice,
tutorial.
nice,
Yeah, it's great. It's great.
nice,
And
awesome.
that was
Yeah,
using Penny Lane, right? That was access to Penny
it
Lane.
was
Yeah.
exactly,
That's
yeah.
fantastic. Use Python, my new favorite programming language.
Python,
Absolutely.
yep,
Oh, love
yeah.
it. Love it. Yeah, yeah.
And it's kind of interesting. Let's go back to, I forget, Apple One came out maybe in '75 or
Hmm.
something around there. And imagine if you had the internet there. It's a really kind of interesting thought experiment. If we had the internet back then, per se, I wonder if the first use cases access will be, instead of buying them, you can just log in, pay a few
Yeah.
dollars, and use it online.
Hmm.
Of course, that didn't happen, but um,
But
you
that
know,
was how things were before that. I mean, that was it was all about getting terminal access to larger
that's
computers.
true. That's
Yeah.
true. But it wasn't. That's true. It wasn't in like a user friendly sort of
Oh no, no, no. You sort of had to bow to the acolytes of the computer. Yeah, yeah.
That's true. Yeah. So it wasn't really mass appeal then. But in terms of your question, where we are, it's really hard to sort of say. I've heard people say we're at the vacuum tube phase of
Mm,
the 1940s.
mm,
But really, because we have computing already, it's not like starting from the beginning.
mm.
So we use a lot of classical compute already for our simulations. Our quantum computer has a lot of classical compute. So it's kind of, you can see some elements of the vacuum tube. You can see elements of data centers already. So
Mm.
it's a bit of everything, which is what you want. You don't want a new technology to be fully reminiscent of an old technology. You want to
Right.
say, well, looks a bit like that, it looks a bit like this. And through those similarities, you really create new technology.
Mm. And there's definitely a danger. I see it a lot of people comparing them to PCs all the time, and it really is a different way of computing, isn't it? I mean,
It really is. And PCs, I do believe you'll have a quantum computer in a laptop one day. The question is when. It won't be this
mm,
decade for sure.
mm.
But particularly with our approach, where in principle we can have nearly everything and ultimately one day everything at room temperature. So no cryogenics, no laser cooling, no nothing, where you can shrink it down using our approach. But not this decade. So it's more kind of like AWS or Azure, where you're
Right.
booking time online to access these.
Which we're
NVIDIA,
doing with traditional computers, anyways. I mean, the reality is, I mean, for some
yeah,
of the Chat GPT, for some of the machine learning models, you've got online cloud computing. So yeah,
exactly right. Yeah,
yeah,
well, you wouldn't have the resources to do any training or anything like that. You're really
yeah.
accessing these large data centers.
It's amazing. And you guys, so the computer I would have access to do my programming would have been one of your wonderful fridges that are running in the tower there.
Yeah, so it depends. What's great about Penny Lane is it doesn't care what hardware you use. So
Ah,
you can actually log in and create an account and run stuff, and it just uses your computer. So classical compute, just to
mm,
play around. And, a Hello World example doesn't need
yeah,
powerful quantum compute.
right, right.
But it allows you to now start playing around with the language and using
Mm.
Python, like you mentioned. Or you can actually use Penny Lane as the gateway to our hardware or anyone else's hardware as well. That's what's very unique about Penny Lane. So yeah, depending on what your goal is, you can use a variety of things to leverage Penny Lane on.
That's so smart because that's very similar to the early PC days where we're trying to figure out what is the operating system that's going to run this because obviously that's going to be whoever that player is going to be in a great position. Um,
100%. Yeah, yeah,
wow,
and
it's exciting.
it is, and that's why we've made Penny Lane open access. open source and available no matter what hardware you use,
Hmm.
because people really love it. They can use our hardware, that's great, but they can use anyone else's. And it is kind of a race to a million qubits.
Hmm.
And so if some people don't make it to a million qubits, aren't sort of the first ones through the gate before the gate closes, then we can potentially get more users using our hardware,
Hmm.
provided we're one of the first few to get through, obviously.
Right. But it also covers your bases too, because if you've got a system that can run on anything, that is an aspect of your business that I'm sure will be valuable as well.
True.
I mean,
Exactly.
that's
Yeah.
great. I guess the next question is, what is the promise? There's so much promise to these things. I'm curious to know why batteries, material science is where you went. I would have, because the stuff I always hear about to start off with is like, oh, we're gonna break this, the cryptographic systems, and the banking's gonna collapse, and you know isn't everyone's goal to crack crypto, or cryptography?
Well, it's a really, when you go to raise money, and we've raised quite a bit. When you go to venture capitalists, it doesn't look too good when you say, "I'm going to break the law with using this."
Okay, yes, this is
So
why I'm not in business. But that's certainly one of the fears that this thing will.
it is,
Yeah.
particularly from, we've received so far about $40 million USD non-dilutive funding, both from the Canadian and US governments, and
Right, right.
that alludes to the fact that these, governments all around the world really need to keep an eye on this technology,
Yeah.
and will probably need to use it for this reason. Now, the good thing in terms of security, though, is quantum computers can hack current security, internet security.
Mm.
They're not big enough yet to do that, but in the meantime, you can actually there's other codes or encryption techniques that a quantum computer cannot break,
So this is the
and so
post
that's
quantum security stuff that, yeah,
exactly,
yeah. So we
yeah. So
basically already solved that problem's sort of.
that problem's solved,
Mm.
but the implementation is not there yet. People need to implement it far widely. But what's interesting is that any government in the world can download any information now. So think medical records, patents, and other things that
Mm.
need to be secured potentially for decades.
Mm.
You can download that now. So if a large enough quantum computer is available in 10 years, you're going to have 10 years of information
Yeah.
that needed still to be secret. And so you can download anything now. It doesn't mean you can look at it or decrypt it. But so the longevity of certain information really matters. Let's
Mm.
say you and I were talking in secret today. Maybe it needs to be secret for 24 hours, but it doesn't have to be after that. And then it doesn't matter.
Right.
But there are longevity sort of use cases that I mentioned, patents, health records. They need to be secure for an average lifetime, say 80
Mm.
years.
Mm.
So that's why things need to be rolled out before a quantum computer gets big enough.
That's interesting. There's always this sort of shadow side to any wonderful new technology, because I mean
Yes.
the reality is we've been talking to Earth scientists, Earth observation scientists, and some more sort of environmentally friendly stuff, and they're saying, and space exploration, of course, and they're saying like we can go back to all this old data and use all these new technologies on it and make new discoveries. And you're saying yes, you could also go back and decrypt all of this stuff that's supposed to be secret. So yeah, we're amazing at figuring out horrible ways of using these technologies as well. So what do you think? Is Canada going to be a quantum power? That'd be rather nice, wouldn't it?
It has to be. And that's one of our mission is not that, but we need to do that. Our
Mm.
mission technically is to build quantum computers, make them useful and available to people everywhere.
Mm.
But you look at Australia. I'm originally from Australia. You see similarities there. You know, Canada has not been great at commercializing
No,
these things.
no, yeah,
A lot of the talent maybe starts here, but then moves to the US.
yeah.
So we want to be one of the few examples where this does not happen, and we really want to be. There's a number of great quantum companies here in Canada.
Mm.
How do we become world leading
Mm.
and be really Canadian at the same time? So it's doable. The Canadian government has invested a lot of money in terms of the talent, in terms of
Oh,
universities.
good, good. Okay, so they've been supportive.
Exactly, and that's through different institutes and universities. So we have the talent here. In fact, out of our 220 people, around about 50% are from overseas, but the other
Mm.
50% are homegrown talent. So not only are we giving jobs to people here from Canada, but we're also doing a brain gain rather than
Right.
the drain, which is really hampered historically. And a lot of founders want to first thing they want to do is go to the US. There's more money,
Yeah.
maybe more prestige, but hopefully we can set an example that doesn't have to be a first port of call.
Oh, that'd be wonderful. I mean, because it really is. I mean, look, we have the same issue with the film industry, where it's just you get to a certain level here, and then you go down the states because that's where all the money is.
Yeah.
Um, hey, if quantum actually now I say this, if quantum computing is so good at simulating, are we going to see quantum computing used to create some of the worlds we see in films and television stuff? Is that something that it's, or is it just too ridiculously expensive at this point?
Yeah, it's unclear. This is one of the things that's amazing about quantum computing. We have a lot of applications now, but I think most of the applications will come once we have 1 million qubits, or what
Right.
we
Okay.
call a quantum data center. People just playing around and discovering things. So it's so hard to predict the future in general,
Yeah.
but even more so with quantum computing. So who knows is the answer. It won't solve every problem faster. It's not going to load Facebook or Instagram or our
Yeah.
emails faster.
Yeah. Yeah.
It's unlikely. So, yeah, but the use cases are quite impactful if it does play out.
Absolutely. I mean, the battery one is fascinating because that's it. That is just such a. It's actually. Yeah, I'm very impressed with that as a choice because It is such a problem right now. I mean, power, as always, is an issue, and we've got to become more efficient and more sort of, I guess, ecologically friendly with this stuff as well. We're almost at half an hour, so I should go and check and see if we've got any questions for you because I'm hogging all the time here. This is so I find this stuff absolutely fascinating, and I think it's one of my favorite things are a technology that you feel like you could be a part of. People could be a part of the beginning of this.
Yes, yes.
They can go in there, they can start messing around with this code and trying out Penny Lane and saying, hey, why don't we use it? Oh, look, it works really well for this, or it's just so much fun. All right, I'm going to pull this up. Here's another question for you. I'm a big fan of Australia. I've been there a number of times now. Uh, what was it that drew you to Toronto?
That's simple. It's just work related. So I was finished my PhD in Australia, and it's typically you're encouraged to find a different group, preferably overseas, to work with.
Right,
So after that, I was a postdoc at MIT in Boston, and after that, I got a job in Toronto.
right.
And then that's where the story kind of started. Once I landed in Toronto, I thought I love Toronto. I'd love to stay here a long time.
Yeah.
And then just did 2 postdocs here at University of Toronto, and
Oh, U
then
of T, great. Yeah, yeah,
yeah,
yeah.
yeah, and then just decided to start Xanadu here.
That's fantastic. I'm just trying to get my into my email now because, of course, I've neglected to open that while we were talking. It's funny because Australia and Canada are very similar. I feel about
Yeah,
innovation. I think we're very they've got some very smart, very well educated people, but they do tend to get drawn away from their own country, aren't they? I mean, it's a very similar issue.
yeah. I talk about on the one hand, I'm talking about how great Canada is, which is true,
Hmm.
but I did the same thing. I left my country of
Yeah,
origin.
there you go. There you go. Well, I mean, I like Australia and Canada. I feel have there's a nice bond there. I know whenever we went there, everyone was always the thing that I couldn't get over was that everyone was amazed that we could live here because how could you possibly live with bears? That was the thing that kept coming up for me. And I'm like, wait a second, you're surrounded by every poisonous creature on the planet, but you're worried about bears. All right, got some questions for you. This is from Aaron Fritz. Aaron Fritz asks, how do you keep the conductors from overheating?
Um,
The conductors. So what, the getting into the chip? What are the conductors?
I don't know what he means by the conductors there.
All right, so how do
Um,
we keep the chips cold? I've seen these in action.
so the chips actually get quite hot when you control them, but yeah, I mean the chip's just like any other chip, doesn't heat up. So yeah, it's not an issue for us. In fact, what's really good about our chips compared to nearly everyone else is most of our chips actually run at room temperature. So no laser cooling, no cryogenics.
But how? I thought the whole point of the quantum thing was it has to be like cold and slow to work.
No, that's what's really great about our photonic based approach. So if you think of the ultimate goal of 1 million qubits or this quantum data center that I mentioned, then only 10% needs cryogenics. The rest is at room temperature. So we do have some cooling that you would have seen,
Right.
but it's far, far less in terms of the overall footprint. Now, we do need some cooling because you need to really escape from our world.
Hmm.
You really need to cool things down near to absolute zero so things are not really moving and there's less noise. But for the most part, a lot of our stuff, because we work in a regime of photonics that's different from everyone else pretty much,
Mm.
that we have the ability to actually be okay with room temperature
Mm.
fluctuations. They don't really cause us any problems.
So if you're not using photonics, you're using some kind of exotic materials of some sort. Is that what are the different branches you can take with this?
Yeah, so we use photonics as the medium where we encode information on,
Hmm.
but we have a few different types of chips
Hmm.
that or waveguides that the laser light gets coupled into. So we shine light essentially through waveguides. They're made of different materials, different types of silicon,
Hmm.
essentially. 3-5 materials for the detectors, and also the light will transverse through fiber as well.
Right.
So you have a whole bunch of chips, and then you also have a whole bunch of fiber optics that essentially make up our computer.
I couldn't get over watching someone actually putting together these strands of fiber. It's
Yeah.
just extraordinary. Okay, so how does AI go to help work out how to make it better or take over the world? All right, so this is a question from Glenn Corrigan. Says, how does AI go to help work out how to make it better or take over the world? I suppose. Yeah.
Take over the world. I can't comment
Yeah, we can't.
on
We can't speak to that. We can't speak to
can't
that.
speak to
Yeah.
that.
Yeah. Yeah.
But we use a lot of, AI is, you hear it particularly in AI companies that are trying to raise money.
Hmm.
They're all AI. AI is really, some people compare it to electricity, meaning that it's just there. We all use it. We don't even have to say we're using it, kind of thing.
Hmm.
It's so prevalent. And so we're actually using traditional AI a lot in really end to end in our company. So one simple example would be we use it for chip design.
Hmm.
So that's used there. We also use AI sort of techniques for things like the optimization side of our computer from a
Right. Right.
theoretical point of view. It really is everywhere. We also have this cool thing the team did internally. We've got our own quantum chatbot on our Slack channel,
Oh yeah.
and that's trained on data that we care about. So, for instance, for our photonic architecture, we can ask it, things, what paper has this, or
Ah,
actually
smart.
ask it photonic quantum computing
Right.
questions. It'll give us answers as well. It's still early days, but so really, it's just another tool. There's a lot special about it, but there's nothing special that we're kind of an AI first company. It's just everywhere anyway. So
Hmm.
we look at it as another tool and see how that can help us build our quantum computer faster.
What about running AI on the quantum computer? Is there any advantage to that, or are we still trying to figure out whether that is the case?
Honestly, in the near term, we're still trying to figure out what that is.
Hmm.
I do believe, along with others, it's going to be quite impressive. Once that's the field we call quantum machine learning or quantum AI.
Hmm.
What's interesting at the heart of both of them, the mathematics is linear algebra, so that's a good start.
Right. Right.
Uh, and in the long term, once you have a very powerful quantum computer, there's certain things that it can do that's quite remarkable for AI. In the near term, we're still trying to figure it out. The hope is, though, that we're hearing about the models are getting very, very complex just in general to train
Yeah.
classically. Maybe once a quantum mechanical model that's still tough to train, but easy for a quantum computer could be a way to go. Another answer is we're still looking into is perhaps synthetic data. So I mentioned this quantum synthetic data. So I mentioned
Hmm.
this demonstration that we did where it's generating information data that would have taken 7 million years to generate. Maybe there's certain synthetic data that would have taken 7 million years, but we can use it now. Now
Of
the trick
course.
is yeah, the trick is generating data that has value. We can generate data, but how do you generate data that has relevance to
Hmm.
traditional machine learning problems? So a few things we're looking at now, but I'm sure something will materialize that will be very important in the near term.
And is this something? Are you really? Is this just like? Are you just grabbing the threads from all over the place, or are you having to ignore some and say like we're not focused on that. We're just going to focus on like material sciences or whatever.
Yeah, we're hardcore focused, and the reason is that let's take the battery as an example. It does have, it is transferable or applicable to things like quantum chemistry in general and other types of material design. So we do have that transferability.
Hmm.
Having said that, if we focus on batteries, we're not battery experts. The team's getting there,
Right.
but it now means we have to partner with those people who are. And so we partner with a lot of the car companies, Volkswagen, BMW, Toyota, and so forth.
Hmm.
They provide the battery expertise. We then have to hire people in batteries.
Hmm.
And so you can already see that if we stretch ourselves too thin, like go to any of the other industries like
Yeah.
um, pharmaceuticals, drug discovery. So we'd have to do this all again, and we're
Right.
spreading us far too thin. So we also want to patent things that we do. So specialize in batteries is the first step, knowing it has applications outside of that in more general material design.
No, that's great. That's great. And I guess when you've got a new field that could be capable of doing anything, it's probably good to focus.
I think so, yeah.
How we do for time? I just want to make sure. I'm very conscious of the fact that we've got you for an hour. Okay, so other questions. You have a unique background merging business acumen and physics degree. What top 5 books would you recommend reading for someone who wants to follow your steps? Ooh. Well, the Rockefeller one, I guess, is one of them. So
yeah, there's the Rockefeller one that's called called Titan. That's great. I love the book on Steve Jobs and Elon Musk by
Oh yeah.
Walter Isaacson.
What the two together in one book?
No, just separate books.
Oh, I see.
I read them, I read them both a number of times now, and always come back to them. So, really, my recommendation is just find any biography that looks interesting to you. So always start from the point of view is what gets you excited, what do you enjoy. So another one I've read many times, which I absolutely love, is Snowball, the book on Warren Buffett. That's great. And a lot of these ones that I mentioned, is thinking none of them have anything to do with quantum physics.
You got any quantum physics suggestions out there? Yeah.
Well, I like the famous one on quantum information and quantum computing by Michael Nielsen and Ike Schwann.
Okay.
That's good. That's very technical, but that's a really fun one to read. And also, I'm also been reading the last couple of months books on the first 25 years of quantum physics, and that's just fascinating.
Is that Feynman and
not Feynman, because he typically came after the first 25 years. So the first 25 years starts at roughly 1900 to 1925.
Oh, wow. So, I didn't realize it was that far back. Wow, okay.
Yeah. Actually, 1925 is the year of quantum, 100 years this year.
Oh, wow.
But that would be the characters of Bohr, Einstein, Dirac, Heisenberg, Schrödinger.
Oh, yeah.
All those guys, and it's just fascinating reading about how they came up with this stuff. A lot of it is just intuition, a lot of it is mathematics, but a lot of it is crazy ideas, some that worked out, some that didn't. So that is very fascinating. And again, it comes back to, does this get you excited?
Yeah.
And if it does, read more. If it doesn't, choose a different topic. Find that excitement, because it's a shame, it's a wasted life if you get up each day working on things you just don't find interesting.
Yeah.
I think that's really important.
Hey, that's why I do this. Every week I get to talk to someone doing fascinating things, and I get to learn something in the process. So, awesome. And if people watch, fantastic. You've just mentioned something which I have to bring up, which I know is so cheesy, but I was so delighted to hear this. The name Xanadu and its connection to those first 25 years of quantum. Yeah. Do you want to let people in on that?
Sure. So I wanted to first call the company the Beatles.
Right.
That didn't seem
copyright issues.
Could be problems there.
Yeah.
And then I thought, well, how about McCartney? No. How about Lennon?
Right.
No. And then I thought,
wait, no Ringo?
No, I didn't make the cut.
Because I think Ringo sounds kind of quantum somehow.
Yeah. Then I remembered one of my favorite bands was Electric Light Orchestra.
Oh yeah.
And that has light in it, so that's like, well, that's kind of cool. And then I thought, well, who was the lead singer? Jeff Lynne. And I saw him play with ELO. ELO's Jeff Lynne a couple of months ago in Toronto. It's fantastic.
Oh, really? Wow, I didn't even know they were still playing. Jesus.
Yeah, it's their farewell tour. And Jeff Lynne, anyways, I'm getting there. Jeff Lynne wrote the song Xanadu. And I thought, well, Xanadu sounds kind of cool. And I always loved as a kid the album from the movie. Not the movie so much, but the record.
Yeah, the movie was a bit of a disappointment, wasn't it? Yeah.
It was. The album is so good. Side 1 was Olivia Newton-John. Side 2 was ELO.
Yeah.
And so that's where the name came from, the song from the movie. But to your point, Olivia Newton-John, not many people know, her grandfather was Max Born, which was also, I should have mentioned, one of the leading physicists of the last century.
Yeah.
And she's Australian, and so that's kind of the journey.
It all feels very entangled, doesn't it? It feels very wonderfully quantum.
Exactly.
Okay, there's another question here. Between reading business books and biographies, do you read any or watch any sci-fi? Any pet peeves in how they portray quantum physics? Oh my God, don't even start me on that one. Or science in general. You any sci-fi at all, or you probably don't have time to read it, do you, or watch it?
I love movies,
Mm,
so therefore I love science fiction. So
mm,
I'm not a Trekkie, but I love all the Star Trek movies. So
right, right.
yeah, I watch all genres. I don't mind too much. It depends again how hardcore you are, but I don't mind that Ant-Man had a lot of quantum in it.
It did have some questionable quantum, I'd have to say. Yes.
Yeah, and if you treat it as just a movie, it's fine, and it also gets people talking about quantum computing and maybe
Yeah.
seeing what is this stuff. So I think overall it's a positive thing. So I have no real qualms about that sort of stuff.
It's interesting though because there's some. I find that people come into these things. Often science fiction is seen as sort of the first stage of engineering. It's like the dreaming phase. Quantum seems like is a hard one because it's used as it's a very sort of easy solution to writing problems in a lot of these films. Um,
That's
uh,
true. That's true.
so any particular favorite ones that stood out for you? You sort of went, oh, I like that.
Mm, I can't think. Oh well, I love yeah. So I love anything by Christopher Nolan.
Oh, really?
Anything, and I always love how he's got like he's got like I want to write there's always these genres and like a burglary sort of
Yeah,
thief genre,
yeah.
and then he combines that
With Inception. Not
yeah
well, yeah. There's Inception. Also, what was the other one?
Interstellar is
Oh, we just watched Interstellar again. Yeah,
yeah, I actually saw that. I went to Scotiabank and watched the 10-year anniversary on IMAX, and
yeah,
that was so good. So I love how he kind of brings, my favorite one of his is Tenet, and he talks a lot about a bit about Oppenheimer,
yeah.
and then the next one after that is Oppenheimer. So
Mm.
his new one, I can't wait. That's going to be seems like a departure.
What is he
Matt
doing
Damon,
next? What's he doing next? Just
Homer's Odyssey
oh, that's
is
right. Oh, yeah,
so
right.
that'll be fascinating to see.
Yeah, I wish they had that when I had to do that in school because I'd much rather watch the movie. It's a bit of a drag to read. Interesting. Yeah, that's interesting because I've always feel that Nolan is a very sciency filmmaker. If that makes it. Him and James Cameron as well, who strangely I find his films don't always equate to the man I hear talking about the science behind the stuff. But
Yeah, so
uh,
I'm actually reading. I got from a secondhand bookstore the making of James Cameron and Titanic.
oh yeah,
I often George Lucas and Spielberg are very
yeah,
big for my. I
yeah.
actually like. I want to create my own Star Wars,
Ah, yes,
and that is hopefully Xanadu. But you find similarities, as I mentioned before. James Cameron, when he's making the Titanic, it's very technical, very
yeah,
sciencey,
yeah.
and then he tries to kind of make a science project come alive in terms of a movie. So I read everything and anything about I can about directors because I see them as kind of being entrepreneurs as
Absolutely,
well.
yeah, absolutely. I mean, and it's one of the reasons I fell in love with. I got stuck in the acting stuff, but I love all the technology that surrounds this thing. So yeah, it's a huge influence. Okay, just gonna double check, make sure there's no more questions, so I can hog you for a little bit longer if I don't. There we go. Okay, so we're clear for questions. So I'm going to ask you one more. Getting into this, if someone is excited about this, they go, "Wow, this is something I want to explore." What is the best route into something like this now?
Well, now that our company is like 8 years or more into things, it's very different to when we started. When we started, honestly, the first 80 or so hires all had PhDs.
Hmm.
That's quite remarkable, and that was the only way to get in.
Right.
Now, what's interesting is, we've got HR, we've got finance.
Yeah.
People need to get paid,
Yeah. Yep.
and we have a business team. We have software developers. So we have a lot of things that look like a normal company
Hmm.
rather than the early days. So the reason I bring that up is that there's room now for just non PhDs in physics to be part of this. So that's
Hmm.
the first thing. It's like if you're in HR, check us or others out. If you're in business, check others or us or others out. So it's far more wide open now. And then I would just say, depending on whether you're in HR, whether you're want to be part of Penny Lane, so you're a
Hmm.
software developer, Python, just look at the videos that are on things. So, if you're in business in that, watch some of our videos where we've spoken at conferences
Yeah.
or look at other companies, whatever it is, just whatever you're excited in. if you're interested in software development and maybe be part of the Penny Lane team,
Yeah,
go
definitely.
yeah, go to pennylane.ai and see the tutorials that we have there.
Hmm.
So another one is we hire chip designers that may or may not have come from quantum. These days, not from quantum. They're just sort of chip designers from NVIDIA,
Right.
Intel, and so forth. Then check out some of our technical papers on that and see if that if you get excited by the substrates that we use or the types of things that we're putting on the chip. So find out what you love, what you're interested in, and find that particular category at our company or others.
So there's a lot of different ways into it at this point now. It's
There is now, yeah,
right.
which is good.
That's fantastic. Look, I don't want to take up any more time than you have. But if you do have time for a couple more questions, I will launch in. Okay, so I guess the next question is, where do you see things? Where do you see things? I know you don't like predicting the future, but where would you like to see things in the next maybe 5, 10 years?
Well, 10 years, well, 10 years, roughly speaking, I hope many more applications have been developed that we just don't know about today. And that would
Right.
be really great. In terms of the next 3 to 5 years, for us is building a quantum data center here in Toronto.
Right.
So that's the vision. And think of that as being equivalent or having a million qubits. So really, you've got this center or this data center that can now solve important customer problems.
Right.
So it's really those two things. Very simple to say, very hard to do, but they're our North Stars, particularly the quantum data center, because you need everyone working together in building this data center. So that's how we kind of see it.
And is that something that's going to be accessible to? I mean, maybe not everyone, but is there what is the sort of the cost of entry of something like that? Is that going to be something that's going to be accessible like Amazon Web Services, or is this going to be a more sort of academic and big corporation type stuff?
It'll probably be everything, but heavily weighted towards large corporations.
Hmm.
And then secondly to academic groups, because, you know, by that time we would have raised a lot of money. We need to pay back that money and pay it
Right.
back with interest.
Right. How much money are we looking at now? What have you? How much have you raised?
So far, we've raised $250 million USD,
Wow.
not including about $40 million non-diluted from the Canadian and US governments as well.
Wow. So this stuff is expensive.
Very expensive. When you're creating something that could be on par in terms of impact with digital computing in general and also the internet, it's going to cost a lot of money, but the return hopefully be a lot of money as well.
There's an interesting question here about whether when you're using it, will AI can AI help you solve the problems with AI? Like, can it be used to help figure out some of these sort of interference problems or scaling up problems?
Mostly with, mostly I would say with things like chip design,
Hmm.
optimization of the architecture, things of that nature is really where it can play a role.
Hmm.
And we'll see whether quantum and AI can merge together to give you something pretty amazing as well.
Hmm. Thank you so much for this. This has just been absolutely amazing. Yeah, I cannot thank you enough. This is you've taken an hour out of your time to answer some of these questions, and I really appreciate it. If people want to get in touch, maybe not get in touch, but what's the best way for people to sort of reach out? Obviously, Xanadu.ai would be the starting point, I guess.
Well, I always check my emails too. So it's Christian at
Oh, great!
Xanadu.ai,
Wow.
either there or on LinkedIn too.
How on earth do you manage that? Because I my inbox is a disaster. You've got to have some computing working
Uh,
on it.
I I'm very hardcore with it. I make sure I reply.
Oh, really? Oh, are you an empty inbox person? Are you like one of those clear?
Not so. I have actually. I see my work inbox now. I have 70,000 unread.
Oh, okay,
But
good. So
what
you're
I
like me on
do
that now.
is, yeah, I have a star section at the top.
Right.
So anything that's important, I star, and I make sure I read all of them. Anything else, I don't bother opening. So now I haven't opened 70,000 emails. So that's like, let's say a second per email. That's 70,000 seconds
Yeah.
saved. So my personal one, I think, has a quarter of a million unopened. So I kind of structure it that way.
I feel like we're trying to sip out of a fire hose the amount of information we've got going with this. So this technology needs to help sort of reduce a lot of it for us. Are you using AI for that kind of thing as well? Your AI assistants at all?
For
Or?
that sort of, no, I haven't really got into that yet. I don't really use ChatGPT. I've tried it once or twice, but yeah, it hasn't really. inserted itself in my day-to-day life yet. We'll
I,
see.
I was using it with Python, it's actually specifically with working with the Penny Lane stuff. There was some I ran into some configuration issues on my side and was working with it to figure them out, which was it's really I've got to say from a coding perspective, it's like having a coding. Jesus, I knocked my microphone over. It's like having a coding tutor with you the whole time. It's just I'm yeah, very impressed. Yeah.
Yeah, it's amazing.
All right, I should let you go. Thank you so much for this. Thank you to the whole team out there as well. For making this happen. Raf for taking us around as well. And I really hope that Canada continues to support this because I think it's really important. We present ourselves as the quantum power we could be, and it's fantastic.
100%,
Thank you,
100%.
thank you very much.
Thank you so much.
All right, cheers. To believe it, Jane. I know it's kind of extraordinary, isn't it? Well, I knew we only had an hour, and I was worried. I didn't want to eat up his time, and we covered all the ground incredibly quickly. So I just thought I would pop back on and say hello to everybody and see if there's anyone questions or anything like that before we get into it. Before I get back to my exciting life. All right. That was amazing. Oh, thanks, Aaron. I'm so glad. Yeah, I've got to say, I know how valuable his time is, and not that everyone else's time isn't, but I, from a business perspective, I guess it's time is money. So I didn't want to eat up too much of his time. But what an exciting sort of quantum future we have. I just love the idea that Canada could be the place to go for this stuff. Like, I thought we had it there. We had it there with BlackBerry for a bit, but this technology is even, this is even better. Hello, Kaylin. Hello, Troy Parker. So while I talk to you, I'm going to do a little bit of boring administrative stuff. I think you'll like it. But I just wanted to get some questions in here. See if anyone had any questions or comments. So Aaron, you're into this quantum stuff? Yeah, it is amazing. I had no idea there was such a history to it, that it had been around for so long and there was so much going on. I didn't want to get into Microsoft's new announcement because because I just felt that was a whole bag of worms that I just don't think I wanted to force him to chat about some other company's work. But they've got this new topological quantum computer that they're working on, which uses these Majoran particles, these amazing particles that are their own antiparticle. I talked about it in my email of awesomeness this morning. So hello, Caliber Pictures. Hello, Corin Horn. It's a tad loud. Well, let's bring it down a little bit. How about that? Is that better? It's just because I'm excited. It's because I finally got to my coffee. That's why. So I am in the process of figuring out the file itself. I want to get the file back up there, but I want to also just do a little trim on it before I do that. There we go. Oop, there you go. There we go. Let's see if I can do this. So sorry. So you're going to have to listen to me edit while I do this. There we go. There we go. There we go. See how this works. That should do it. All right. How do I do this? New cut, preview. Is that, I'm going to preview it? No, I'm not going to preview it. I just want to edit this. Anyways, so questions. What do we got? That's better. Earlier, Mike was kind of overpowering and his was a bit quiet. Oh, not again. Oh, damn it. Seriously? What a drag. I keep screwing up the sound on this stuff. I'm going to get rid of this transition thing because it's driving me a bit crazy. How does this work? Do I get rid of that? Nope, it doesn't work. I've got this transition thing that I was trying to use, which of course I completely screwed up. But bonjour, Max Porter. How are you? Yeah, now you can hear a hairdryer in the background as well. But I think this mic's pretty good at removing that. My inquiries go into the idea that go with room temperature cooling superconductors in tandem with quantum computing. My inquiries go into the ideas that go with room temperature cooling superconductors in tandem with quantum computer. Yeah, the whole superconductor thing seems to be a big part of it as well, which is interesting. That's better. Earlier, Mike was kind of over. Okay, here we go. No, Agna does not like being on camera. So, and was not supposed to be on camera. So I'm actually going to remove that as we speak. Where do you find meet your smart friends? Agne, Janelle, honestly, it's Agne's just amazing at this stuff. I guess she's met a bunch of people through the NASA program she was a part of, and they've just been incredibly receptive to coming in and talking about this stuff. I mean, again, what's nice about the academic side of stuff is that the outreach and stuff is a big part of what they do. So that it's not, they're sort of more familiar with that. The business folks, I feel a little bit more nervous about because I know how they literally valuable their time is. I mean, the guy we were just talking to raised $250 million for his company. It's absolutely extraordinary what he's done. I mean, that's kind of unheard of in Canada, as far as I know. I mean, whatever I know. How do people even realize that they are that smart? Like, some people just understand that stuff easy. I don't think so, Ashton. I think there's some people who just have an intuitive understanding of things for sure. I do think there is a certain amount of innate intelligence that people have. But honestly, I just think that, if you start doing something and people reward you for doing that by saying, "Oh, that's cool," or helping you do more of it, you get excited about it. If you think you're good at something, you get excited about it. You continue doing it. If you think you're bad at it, you stop doing it. I mean, so I think that it's just a big part of it is just being inspired to follow up on this kind of stuff. I am constantly worried about how little I know, constantly. I don't understand how these people get to where they are and how they're doing what they're doing. I am absolutely in agreement with you, Ashton, on that. I don't know how they do it. All I know is, from my perspective, the stuff that I've got better at is the stuff that I've had help and people have championed me for. It makes a big difference, I think. I, Paul the X, loves the Dalek poster. Well, thank you very much. It was a gift to me, a fabulous gift. It's kind of just nice to have a Dalek, peering over your shoulder while you're doing this stuff. It was a great interview, discussed in an accessible way that makes sense. I was wondering if an industry you'd consider working in now you know more about it. Oh my God, Kaylin, I'd love to. The quantum stuff is absolutely fascinating to me. Hang on one second. Is that... Does that work? Is that gonna let me save this? That would be nice. Save. Save as new. There you go. I think I can save that as new. Great. That can be now public because it doesn't have all the things I wanted it. Title is too long. Sorry, hang on with me 2 seconds. Let's start. Here we go. And I think that will let me do it. There you go. Saved as new. There we go. We've got our video up there. Woohoo! Great. I think that solved the problem. I promised Agni I wasn't going to show her on camera, and I feel bad that I ended up sort of doxing her at the end there. So I just wanted to just take that off before I put it back live again. I should do the same thing actually on Twitch. I think I can do that as well. There we go. I can do it on Twitch. Go to there. Let's see how that works. God, there's just so much stuff, so many things to play with. Anyways, it's off the YouTube side of stuff. So yeah, what are people's thoughts? I'm curious to know who else should we be talking about? Who else should we be talking to and all? Some way, give me tech and I got you, but coding, we're both toast. Coding, I'll tell you, if you want to get into coding, I have found the ChatGPT to be absolutely amazing for that. Like just a fantastic tool. It's like I was telling Christian. I went in. I started working with the Xanadu.ai's coding section, and they have these wonderful tutorials there. You can sort of work through stuff. But I was having some issues, and by going back and forth with ChatGPT and having it explain each little element of these things to me, it's just great. It's just a great tutor on this stuff. I mean, you sort of have to know, I guess, I suppose you have to know enough to know when it's got something wrong. But honestly, from a coding perspective, it's kind of a syntax thing. So I feel like if the syntax is wrong, it's not going to work. You're going to spit out errors, and then it can help you work through those errors. So, hi, Paulie, how are you using it? How are you using ChatGPT? When you say use it daily, what sort of stuff are you using it for? A delicious coffee. Sylvia, that's a good question. I finished one of my Coursera certificates. I did a Google Data Analytics professional course that gave me a certificate for that. I really, really enjoyed it. I'm doing the Unreal Engine course, which I'm enjoying less. I found it's I think it's still in flux. I think they're still trying to work in the AI side of stuff a little bit. But the course itself, like the videos are fantastic, and the experts are beautifully expert. I really enjoy the Coursera approach, I've got to say. I think I even have, oh, wait a second. I think I have like an affiliate link. I think I have an affiliate link for Coursera. Wait a second. Can I give you that? That would be great. Because then if you do end up signing up, then it actually helps me out. That would be very cool. Let me see if I can do this. techbandits.org. I think there's a page somewhere in here where I tried a little bit of this. Affiliate links to help fund tech banditry. Here we go. Look at this. Shopify, SiteGround, Coursera. Okay, wait a second. Has this got the... Okay, if I do this, copy link address. Here you go. Sylvia, try that. And sorry, that sounds like I'm just... honestly, the only reason why I'm putting these out there is because I I know that I like them. So the only things that I'm promoting on this, on my Tech Banditry Fund sponsorship thing, are things that I know, that I use, that I like. SiteGround has been my web hosting firm for a million years now. They are absolutely wonderful. I love them. I get a human when I have a problem, and they're often humans who've watched Stargate too, which is really fun. So yeah, I highly recommend them as well if you're looking for the hosting side of stuff. Shopify, yeah, I've got my whole shop, my whole Canardian.com shop is all on Shopify as well. Okay, so someone was saying, would I do? Who was asking about that? I love learning. Would you do something? Where is it? Something I believe quantum. I definitely am looking for other things to get into. Like I would love to have a focus. Like I'd love to be able to just to say like, okay, you know what I'm going to do? I'm just going to focus in on quantum computing for a while, or I'm going to focus in on high powered computers, or bio IT, or or maybe even the other way around. Maybe it's Unreal Engine, something like that. I'm constantly looking for things to learn more about, and this is it's just a wonderful way of doing it. These kind of chats for me are just a great way of doing that. More importantly, when are you coming back to Stargate Atlantis? As soon as they have me, as soon as they want me, I'm back. I'm ready, wherever. Bonjour, Franck. Comment ça va? Très bien, j'espère. More important, there we go. I always wondered what McKay would do if he found himself in Doctor Who's TARDIS. We'll probably fix it, John. Using ChatGPT as a plagiarism checker, too. Many students are using AI to answer their opinion responses. Oy, Deanna, I know that's a tough one. It's a tough one because I feel like the technology's out there, they're using it. How do we use it to help them, as opposed to use it to try to catch them doing the wrong thing? I really worry that the perfect example. So the Coursera courses. I'm doing the Google Analytics course. I get stuck on some stuff. I go through the Coursera stuff. I'll go to ChatGPT. I'll look some stuff up. I'm using it as an educational tool to help me out. And what's funny is while I was doing the course changed. It took me so long to finish the course that they added a whole other section to the course, which was on using AI in data analytics. And their point was basically saying what I was already doing and feeling a little bit guilty about, because I was like, oh, am I supposed to be doing this? I don't know, but it's just how I work, and it's very useful. And I've got this ChatGPT thing. It's, so I was a little worried that it was, that I was maybe I was not strictly sticking to the rules with this stuff, because I was using it as a crutch for some of the learning. And then this whole section pops up running you through how you should use not ChatGPT. They were talking about, what were they using? I think they were using the Gemini, I think. But, how you would use AI in data analytics. And of course, the reality is that we can try to stop kids from using this stuff in school, but the reality is in the real world, we are using this technology. So how do we, I mean, it's tough for teachers because how do you keep up with this stuff? But the question is there a way that they can come up with a way of using, I mean, what if, could you tell them to use ChatGPT to answer an essay and then have them critique that response, or tell you why you like that response or don't like that response, or compare a couple of responses? Because I worry that just trying to shut it down is going to be like whack-a-mole. I don't know how you're gonna catch stuff, how you're not going to catch stuff. At what extent are they using ChatGPT? I mean, are they cutting and pasting sections? Are they rewriting sections? I mean, I always think of back in my day when they had the books and the Dewey Decimal System. When we went go to a library to get a book out for an essay, to write an essay, and you would end up typing in your own version of what a book said about stuff. So it wasn't technically plagiarism, but you might as well, otherwise it would just all be quotes. So I feel like kids are always going to try to hack the system, make things easier, make learning easier. The question is, how can we, sort of twist those tools into something that can be useful to them, as opposed to used to sort of tamp down their ingenuity in using these things. Although my fear again is that I think it could be very, very easy, and there will come a time very quickly where it's just going to be easier to ask these AIs to respond for you. And I really, really worry about that, because I do think that's when our brain starts to turn to Wally mush and we start floating around on deck chairs with giant sugary sodas and things. I mean, like Wally, that we go full Wally basically. I have not seen the recent discovery and creation of a warp bubble. I will have to look into that. The warp bubble. Sounds like something worth looking into. Warp bubble. That sounds like a good topic for an email of awesomeness. All right, what else we got in here? I'm just going to double check my video editor and make sure that it has been saved. Let's see here. I'm just going to go to YouTube. I'm going to the YouTube. Okay, I'm going to view my channel. I'm going to view my videos. And it should be this here. Ah, look at that. That's great. Okay. Good. That's the post-Xanadu chat. The other one is private. Very good. All right, I've saved Agne from YouTube's. Very good. Okay. What do we got? As part, you're always going to try and hack the system to make things easier for yourself. Yeah, it's true. I mean, I think humans have a tendency to try to make things easier, don't they? It's generally it also makes sense. Like, why wouldn't you? Like, why wouldn't you try to? I mean, the very nature of we're building quantum computers to make solving things. If we just went like, no, it's important for you got to get your pencil and paper out and work that stuff out yourself. You can't expect a computer to do it for you. I mean, I remember having one of my essays sent back to me and told that I was cheating because I had a computer type it out for me. I mean, that's just because we had a computer with a printer, and of course, it took a bit of know-how to get the thing typed out at the time, and I remember feeling quite grumpy and frustrated about the fact that the teacher didn't understand that I had written it. It's just the computer had typed it out. Bonjour, Marc-Antoine, comment ça va? Wally is a scare tactic. Yeah, AI will be used for good, but like everything used for good, it will evolve to evil use. Yeah, I mean, look, I think it's I mean, we're the problem, right? I don't think it's the technology. I think we are the problem with this stuff. I had a really interesting chat with what's an email chat I've been talking to the guy who used to do the post Doctor Who stuff, Dr. Dater, and he was concerned. I think this is a really fascinating thing that I had not considered. He's concerned that because of all the wonderful simulations and the exciting world and social medias and K-pop and all these sort of like dreamlike realities that we're given, that he fears we'll lose interest in the real science, in the real boring dusty planets, and the real time it takes to get there, and the pace of science and stuff. And he's put a voice to something that I realized was frustrating me with when I was doing the more of the Tech Bandit stuff. The idea that people they just want to get it done, and there's too many distractions, and there's too many. The attention span becomes very, very short, and I apply all that to myself as well. I mean, I had all of these issues myself growing up, and I think they've only got worse as the tools have become more available to us. But the concern that the one that stuck out to me the other day was when we were talking about this was the idea that we were watching, like, I can't remember what it was. I think it was the Perseverance rover landing, and the kids couldn't care less. They could not care less. And I was like, oh, of course they don't, because they've seen it done already. Only a million times better and a million times more exciting, because there were like lasers and alien attacks and Marvel villains and Star Wars stormtroopers and stuff like that. It's hard. How do you compete with that? How do you compete with a world that lives that's being given these beautiful, exotic dream worlds to exist in? It's just sort of a fascinating problem. I don't know how how do you then make the dusty surface of the moon as exciting as it was back when, Neil Armstrong was on it? You know what I mean? All right, coffee break. All right. Oh no. I just got the dreaded email. The dreaded audition email. I'm not even going to look. Not even going to look now. Forget it. I'll look later. All right. Let's see what else we've got in here. I got my email of awesomeness done this week. I'm trying to get it done before I do my chats, and the idea is to sort of drive traffic to the chats. Because obviously, there's over 1,200 people now on my email list, and which you should join, by the way. If you're here, you should absolutely be on the email of awesomeness, because I think you'll like it. I mean, if this speaks to you, then that will as well, because it's just basically my way of going like, ooh, look at this cool stuff that I see during the week. So I like to send it out. I had my fading using power mug for a year, and it's like new, even though I use it frequently. Oh, I'm so glad. Oh, good. Because mine had an issue. One of mine, some of the paint peeled on it. I think it might be because I bang it around a bit, but Yo, what's up with you, Bast8389? Path of least resistance. Yeah, that's true. AI has the potential of being our greatest achievement or our greatest downfall, and that's scary. I mean, I would argue that about most technologies, though, wouldn't I? I mean, the internet was supposed to, excuse me, the internet was supposed to free speech across the world and communication, and there'll be no borders. And look what happened. It's a whole different world, entirely different. Star Trek. Yes, Star Trek is definitely Star Trek. I was always a fan of Star Trek, but not a real fan, if that makes sense. I was never a hardcore Trekkie. Doctor Who was more my thing, and then once I'd decided to cast aside my Doctor Who obsession, I was all about the film and TV and acting and that kind of stuff. Always science. Always enjoyed the science side of stuff, but weirdly, I've definitely gone more towards the sciences now. Like I definitely find myself reading more science than science fiction. It was really interesting to talk to Isaac Abrams, because that's entirely science-based speculative fiction, so to speak, is fascinating to me, because that's a whole other world of sci-fi that I hadn't really got into. I like a good book, a good thriller once in a while, like a good thrilling sci-fi, or I'm always looking for a good cyberpunk novel. But the reality is, I find the world of science far more exciting right now. It's almost more sci-fi than sci-fi. All right, what questions we got in here? Any questions here? What do we got? Right now, AI struggles to format an email correctly. I'm not worried about it taking over yet. Dead Pixel. Give it some time. I'm amazed at how quickly it's jumped. It's jumped up in usefulness for me. It's always been fairly useful for coding for me. It's now it can now write the code basically. What I'll get to do is I'll get it to write it and then also explain what each line of code does, because I'm like a completionist. I need to know every element of the thing. Because also, I mean, what's the point? I mean, I don't want it to do all the coding for me. I want to do some of the coding. I mean, that's the fun part. But I want to understand it. If it can help me understand stuff, then I'll definitely use it for that. What do you think are some pros and cons when it comes to combining AI and quantum computing? Being an expert in neither, I would say, the pros obviously is if somehow this quantum computing can speed up the at least the learning part of machine learning. I mean, if it can plow through all this data and do all the tokenizing and all that it needs to do in order to create a model that we can use, then I think obviously that would help immensely. And I don't know why I do feel like from my limited understanding of both, I feel like it should help make it, faster and sort of more efficient, and maybe it will be able to deal with some of the weirder elements of the world than it can now potentially, I guess. I mean, does it take quantum computers to truly understand the world? Maybe it will shed a light on the world that could be, that may not be available to us with classical computing. There's definitely pros and cons. I definitely see a lot of pros for it. Cons, I mean, cons. I suppose some idiot could figure out how to, collapse the banking system and I don't know, and figure out launch codes, or I mean, I'm sure there's stuff that will come up. I'm sure it'll be used for phishing people's data and I mean, he was talking about the fact that if we capture all this data and then decrypt it later with the quantum computers as they become available, that is a huge con to me. That is a huge problem, because if you're living in a world where you think everything is secure and then this pops up, it's like, oh crap, I just think there could be some huge repercussions on that. And I think the biggest issue there will probably not be on a small scale thing. I mean, the con there would be that these are nation states. So let's hope we're one of those nation states that we're like, we've got quantum supremacy. Although I don't think that's the right term for it. But I mean, it would be great to be a quantum power. Like, the idea of Canada being a quantum power is very exciting to me. But if not, then I'll go with America or Britain, because I got both those passports as well. Star Trek and Stargate share that technology will always be pushed further. Yeah, I mean, I think certainly Star Trek, definitely, actually, I would say Star Trek for sure, has pushed technology in certain directions. And their sort of utopian type of society is perhaps something that would be fun to explore in the future. Obviously, there are problems with that as well, but I just think that it's you just see so many things from Star Trek showing up in technology. I mean, from the flip phones to the internet, for that matter. I mean, to the nature of society, the fact that it was a very sort of multicultural it was a very sort of multicultural crew. It was women, it was men, they were black, they were white, they were Asian, there was a whole, it was a very progressive I think at the time approach to the world. There's this very funny quote about someone was saying that Star Trek's become too woke. It's like, what the hell? When was Star Trek not woke? There's a whole point about Star Trek. I mean, Star Trek is literally suggesting a future where these things exist. I mean, it just seems funny to me. I was always wondered, David, why wasn't McKay in Stargate Universe? Why wasn't he in Stargate Universe more, you mean? I did one episode, which was a lot of fun. I got to say, I really enjoyed doing that. I was a little nervous because I wasn't sure how my goofy McKay was going to fit into their sexy and and dark nihilistic world. But it was I think they did a really good job of it, and they're just a lovely crew, and and Cast. Oh my God, I love that Cast. They're absolutely sweet. Makes teaching a challenge to compete with Snapchat and Instagram world. Yeah, I mean, are phones banned in your school, Deanna? Is that are they allowed to have phones in school? Hello to everyone in chat. Yes, indeed, Sergeant Bunny, Mr. Sergeant Bunny. Audition for what? Oh, Wayne Taylor, you're just on the ball. It looks like it is a. Let's see what it is. Let's see what. It's so funny. I dread it. I absolutely dread it every freaking time. Here we go. This is what? Yeah. This is a, what is it? It looks like a movie of some sort. No, episodic. No, it's definitely an episodic of some sort. There you go. It is an episodic of some sort. There you go. And it's shooting in, where is it shooting? Let's see. In Vancouver. There you go. Vancouver. I'm in Toronto, of course, so I don't know how that's going to work out. But anyways, important question. Which Doctor? For me, it's Tennant. Oh, it was Tom Baker for me. It was, well, I should say it was John Pertwee to start for me, and then it became Tom Baker. That was I moved on to Tom Baker. That was and that's where my real passion for Doctor Who began. I just loved it. I loved his approach to solving things. I loved his sort of grumpy genius, and I just loved the whole sort of lore around it all, and the whole, time and relative dimensions in space, and yeah, K9 and sonic screwdrivers. Those are the two. I spent most of my youth trying to build a sonic screwdriver because of that show. I just thought it makes so much sense. It's using sound. I just thought it was so smart. Then in the later years, it seemed to become the solve everything pen, but which I don't like so much. But back in the day when it was just this sonic screwdriver that was used to sort of literally pull screws out or fix a little this or a little of that. It was pretty great. There's rather quick ticking sound in your stream. I'm guessing it's a wireless charging phone. Is that right? It may have, it may be messages coming in. It's possible. I think that our brains and intelligence have evolved so far because we had to use them. We had to analyze problems and solve them. AI could replace our problem solving. Isn't that worrying? Yeah, I think Moga. I think that is part of my concern. But I also don't trust our self discipline for that. Like, I think if those tools are there, we're going to use them. We know that social media isn't particularly good for us, but we're still on it all the time. We know our phones aren't necessarily good for us. We're on them all the time. I think I share your concern with that. I am a little worried that a motive. What's the point of learning if everything's just available at your fingertips anyways? Like, if you can get the answer to your question as quickly as you could answer it yourself, then what's the point of answering it yourself? The question is, what would a truly post AI society look like? How as a human would we function when everything we need to know can just be piped into our ear, or potentially eventually, I guess, our brain? How does that change how we live and what we do? I think there's going to probably, my hunch is that perhaps we'll go back to more, maybe we'll pursue, painting and pottery and things that can be uniquely us, or that can express ourselves in a way that perhaps we can't in a digital world. Maybe it definitely begs the question of, if you've got the wrong people in power with the switches. With the switches and access to the stuff that is in fact getting fed into your brain as the truth, I think that's very worrying. I mean, I definitely feel right now that I really want to read 1984 again, because there are just some elements of that are just striking about the world, certainly the world today, and I think that it's about we have the collective knowledge of the human race, and we can't convince our kids to delve into it. I mean, we can't. It's a struggle to compete with the noise and the stupidity of stuff out there. It's all so performative. It's all it's all very look at me. I you know I really do worry about where that's going, and especially if we get to a point where you don't even post your own social, you've got like a system that posts for you. I mean, oh, David's just eaten lunch. I better take a photo, and judging by his expression and the many posts he's done in the past many years, I will put together a post that I can send out, and then automatically any product that he's eaten will be tagged, and any money that's made on the post will then get sent back to his bank account. I mean, like it. That's a creepy future. I said to my wife this morning, actually, we were talking about social media, and I was saying like I kind of wish I wish I could just dump it at this point, because while I love it as a tool to reach out and say, hey, we're going to have these chats and we're going to do something good with this internet stuff. I appreciate that use of it, but that's not how I started with it. I started as it was, a little blog. It was a little way of communicating with people and saying thanks to the Stargate fans and stuff. I now feel like it's become this. It's like an unpaid job where it's like, oh, you got to create content for these assholes, so that they can make money hand over fist and run the world in a horrible way. I feel like. Yeah, I feel like it's somehow become a burden. It's become a job. It's become a chore. I always interacted as I felt like I wanted to, and then now I'm more and more feeling like, well, I sort of have to. I need to, and even when I just go in to post something on one of these, whether it's LinkedIn or Instagram or X or I don't remember all half the ones on my Facebook. When I go in to play to do something, even if it's just a post about this coming up, invariably something will catch my eye, and I'll end up scrolling down, and then you're like angry about something that you didn't even know about a minute ago, and it's a tempest in a teacup. So Tennant was very good, Dead Pixel. Tennant was a very good Doctor Who. Yes, it's true. What do we got? Our feelings, our humanity would be what is setting us apart, compassion and all that. But yeah, art too. The human element will never be replicated. Catherine. Yeah, I mean, I found myself thinking at times, is our imperfection what makes us human? The fact that we aren't perfect at all these things, that we make inaccurate connections on things, that we do, that we make silly, weird connections with things that can titillate or get someone's attention. The fact that we are this weird, mushy imperfection. Maybe that's where our creativity comes. That's where our art comes from. That's where our humanity comes from. But I see the stuff that Midjourney's putting out. I see the stuff that these video generator platforms are putting out. They're extremely good, and they're only getting better. I mean, eventually, they will, certainly at a certain tier of this stuff, at the very least, a certain level of quality and money will be handled by AI. I mean, certainly from a film world, some of the low budget indie stuff, what is the point of having actors in it if you can have a prompt spit out the same kind of nonsense but for a fraction of the cost? Of course they're going to go with that. Of course. There'll still be people will still want us organic beings to be in some of them. There will be I suppose a certain cachet to having humans in what you do, but it's only going to compete for our eyeballs, right? I mean, it's just, and it's when it comes to like VFX artists and color timers and people who actually go in and change the picture to look the right way. I mean, when you can just type in a prompt and say, I want it to look like Star Wars episode whatever, or I want it to look like Seven, or I mean, if a computer can handle that for you, the industry's going to go with it. It's always gone with the cheapest, most efficient approach to this stuff. So yeah, I don't I definitely find myself questioning what is our humanity, like what I think what makes us human is that we, we love, we hate, we fear, we live, we die. I mean, I think there are stakes to the decisions we make that these machines don't have, and maybe that's the difference. I don't think we should be. I don't think we should be banning AI and all this kind of stuff, because I feel like there are definitely things it can be used for. I mean, working with Lance has been extraordinary because we've been using AI as an accessibility tool. I mean, I don't see a negative on that. I mean, certainly he doesn't. So I feel like, but defining, at some point it will be difficult to tell the difference between a human and a machine. It's already getting difficult to tell the difference. And if we're not, there's so many different elements of this, right? I mean, if we also, and then if education can't keep up, then we've got to, and there's no impetus for science and technology, and it's all about what you're told rather than what you learn. There's no skepticism. There's no critical thinking. I mean, if our population gets stupider and stupider and less educated and cares less, then what happens to our art? I mean, our art is, I don't think it's, I think it's going to be I think it's a bit like the early days of synthesizer music, right? Where there was this kind of, it was used in a weird, fun, experimental way with some very smart, forward-thinking people, and then it became this weird, slightly sort of generic kind of '80s sound, and then it sort of went back to sort of some acoustic stuff, and it's definitely gone off in different directions. I think there's a tendency to overuse these technologies, to sort of use them to death before when they first come out, and I think that's where AI is for a lot of things. The hype is huge, but I don't think the hype should take away from what this stuff can do and what it's capable of. So there's a lot of different sides to it. You should just change it to TikTok dances. Exactly. That's it. That's what Twitter was originally good for. One-way announcements and quick posts that you don't care about responses on. It's funny. So that was, that wasn't my response. That's sort of the way I'm using it now. Originally, I felt like there was a back and forth. Like I did feel like it was a good back and forth. Now, I mean, I went on the other day to figure out a problem with this laptop that I had, and I got some great suggestions, and I ended up figuring it out. It's just a terrible design. It was just a pin in the. Well, let's see if I've got it here. So there's a little pin in there. I can see if I can get it to focus on that, if you can see it or not. There's a little pin in there, which is so thin. I'm like ridiculously thin, and it's very, very easy for it to bend. And when it bends, it doesn't connect properly, and and then it shorts out your computer. So the laptop was useless. I couldn't, and you could only charge it using the USB-C if it was closed. So I couldn't. I'm trying to use this Unreal Engine stuff, which is has the computer churning away frantically all the time. So. Have you thought about moving to a more greenfield app like Blue Sky? I have, asteriously. I have, but I'm reticent because I'm on there. I have an account, but my concern is like, do I want to start again? I don't want to start all over again. I have a sort of a fatigue about it. I'm not sure that I want to spend a lot of time and energy and communicate and give that over to some other corporation that may or may not do with it what they will. I mean, wasn't this started by the same person who started Twitter? So what's to stop the same thing from happening? Like, I mean, what's to stop, some insecure billionaire from coming in and buying this one too? I mean, like I guess that's part of it. I feel like I'm already feeding the system. I mean, maybe I'm feeding the wrong system. From what I've heard, Blue Sky sounds a much more pleasant place to be. But that said, for how long, right? Until everyone's there. And then the problem is people. People are jerks, right? It's always, A lot of TikTok is either physics or just avatar. Bast 8389 depends on your algorithm. Honestly, Bast. I mean, depending on what you look at on TikTok. That is the brilliance of TikTok is its algorithm. It's incredibly good at giving you what it thinks you're going to like, and you like it. So everyone's experience is going to be different. It's a weird situation to be in. We all live in these little bespoke realities. We all live in these little I don't want to say bubbles because it sounds somehow pejorative. It seems like I'm condemning it somehow. But we don't. I feel like we don't necessarily go out looking for answers. We go out looking for the answers that satisfy us, that we want to hear. So I think there's a tendency obviously there's a bias built into the little internet spheres that we build for ourselves. So I feel like, I'll talk to friends who go like, "Oh my God, have you seen the big thing about this? There's a huge uproar about this. I've never heard of it." That's not to say it isn't important, but in my very limited use of social media now, it hasn't come up. So, and it's not showing up in my nightly news on the BBC or the CBC. So, unless it's in one of those little realities for me, it doesn't exist. But it is funny how people will sort of go like, "Oh my God, well this is huge. You've got to. How could you have missed this? I mean, it's so important." It's like, no, it's in your feeds. It's specific to you and people who think like you. That's not to negate it, but just that it's what we get. It's what this provides us, and so the platforms worry me quite a bit. You're unique, just like everyone else. It's very good, Dead Pixel. It's very true. I just want to know about rocket ships one day, and I read about world suffering instead. Social scrolling not good for the soul. Yeah, I mean, that's part of it. You go searching for one thing, and then it's certainly for someone like me whose brain is like a bag of cats or squirrels. It is so easy to get distracted from what you are supposed to be focused on. And I really do have to drag myself away from these things. And so definitely my Twitter time and my social media time has diminished considerably. And I don't know. I think that's a good thing, but I'm also in an industry where that's valued, right? Where the larger the numbers beside your name, somehow the more clout you're supposed to have, or the more likely you are to get a job in the industry. I mean, which worries me as well, because I go like, how many do you need? What's the follower count? Because I'll get them. You could just go and buy them. You know what I mean? There's this like sort of, like a lot of the film industry, I feel like there's this pretending that this is how it is. Oh, this is the box office. This is how much it made. This is how much it lost. This is a big star that's going to bring in our movie. Like, it's all based. It's not that. Where's the data? You know what I mean? Where's the things backing this up? It's funny. I sound down on it because I haven't had lunch yet. But the reality is, I am a tech optimist. I definitely see a wonderful future from all these wonderful technologies like AI and quantum computing and this whole sort of space race stuff. I love all of it. But the social media, I was you kidding me? I was in the first round of Twitter followers. I was in there right away. I mean, I was in there when they were like, "Oh, it's the guy from Stargate." You know what I mean? Like, it was a small enough group of people running it at that point that you were connected to them. So I rushed into it more so than most people. I am now becoming more and more skeptical of this stuff. I hear about a lot of new platforms and stuff. I'm always tempted to shiny object syndrome to go in and try it out. But I'm sort of holding off now because I go like, I got enough to do. Honestly, like I am like, I could be as busy as I want to be. And for some reason, I'm busy all the time. I'm writing a book about how technology is inspired by how nature works for the quantum level all the way up. Oh, wow. Cameron Murphy. That's great. You should read Life on the Edge. There's a really fun book about the connection between the quantum realm and the squishy biological life sciences stuff as well. Definitely worth a read. I know it's me, but my AI makes plenty of mistakes. Yeah, absolutely. But so do humans. You know what I mean? So do I. So do we all make mistakes. I mean, it's this. I think what what worries me more about the AI is not the mistakes it makes. It's the veracity of how it tells them to you. Like, this is the truth. It so wants to please. Like, I mean, if you ask for, a review of the three different types of, I want a review of the three different types of Stargate phones that there are. I want the one with 10 megs and the one with 20 megs, the one with 30 megs. If those phones don't exist, it will give you a review of three of them because that's what you've asked for. It's a bit like our bespoke reality where we go out and go, oh, is that the way the world is? And it's like, no, that's the way the world is to us and is being presented to us. So I feel like we share similar issues with this with AI. So AI could decide we're playing at a zero-sum game and just make us go away. Organic recreations. That's, I guess, everyone's fear. And you know where that comes from? That comes from us realizing, I think, that we're the problem, right? We know what we're doing to this planet and to each other is wrong. We know that we should be, concentrated on helping everybody and not being selfish pricks, and that we just, what do we contribute? We build things. Wow, we build things that we like that are a problem for everything from birds to insects. I mean, and everything in between. So I think our fear that AI wants to wipe us out is because I think there's a certain sense of us not deserving to be here, that we are not the caretakers we would like to be. We may be the problem. I mean, that's the weird thing, it's a bit like America. I feel like, as an American, I can say this. We keep talking about the evils in the world, but what if we're the evil? I mean, you know what I mean? Like when we start siding with Russia and North Korea on votes about the sovereignty of countries in Europe. Where I think we're with the Bond villains. You know what I mean? I just think we have to be very careful again that we don't stay in our little bubbles, that we can look around, And I apply that not just this current presidency, although that seems to be a whole bag of crazy unto itself. This is a problem that we've always had. You know what I mean? This is the problem with being an empire. And other empires have had the same problems before. So maybe Canada will become the quantum empire, and then we can be the dicks. Anyways, all right. All right, Catherine, about the human element being our flaws. Yeah, I mean, half my charm is my adorkability. The way I deal with my own mess ups, gotta laugh at yourself. Yeah. But yes, Midjourney is amazing. I think AI art is a thing, and it will stay, and it is amazing in its own right. But I would like to believe that if, oh dearie me, I've just missed the rest of it. Where did it go? Oh, the scrolling. The damn scrolling. What have I done? Damn it. I've lost it. I'm so sorry. That was a really good little tirade you had going there, and I seem to have lost it. It looks like my multi-stream can only handle so many things, and we've got like 126 people? God, no wonder I can't keep track of the tabs of all the chats. Yeah. Oh God. The AI talking to the girl about it existing long before humanity could be what what we might quantify as God or creator. Interesting. It's like a crutch for. Or they say AI is. If Freddiness is saying AI is like a crutch for a broken leg, but for dyslexia and neurodiverse challenges in communication. Like a translator. Yeah, I mean, this is it. I mean, I these things aren't all bad or all good. You know what I mean? And I think there's a tendency. I mean, look at how old the people in Congress are banning this stuff. I mean, I don't think they even understand how to use email half the time. Though it is getting better, I will say that. I just, yeah, there's a fear, I think, that this whole idea of an interconnected world where we all had a voice has made us stop listening. Does that make sense? Like, I feel like we're too busy crafting our responses to things as to how, especially in a social media world where how are we going to be perceived with these things? And I think we have to listen. I think that's where this stuff comes, where I feel, and I believe me, I look at me, I don't never shut up, right? But I feel like what I've been trying to do recently, and I don't know if this is of any use or not, but I have a certain joy out of creating stuff, and being able to put out the email of awesomeness has been very, I feel productive. I feel like I've done something. I feel like I've contributed. And it's silly, but it makes me feel good. So I do it. Could an AI do it? Yeah, absolutely. Do I use AI to help me do it? Absolutely. You kidding me? It's organizing, summarizing. It's fantastic. It goes in and does proofreading for me if my grammar is terrible. Then I go in and change the grammar back to being terrible because that's how I talk. So what I've tried to do is trying to avoid all those shiny new things, right? I mean, and my fear with social media is that I go in and yeah, I feel like no, I'm doing science because I'm bouncing around between all these different new science announcements and fancy videos and robots and like there's too much. You know a little tiny bit. You don't know a little tiny bit. What am I saying? You see a tiny flash of a technology in use, but you don't learn anything about it. So what I've tried to do is I've subscribed to all these freaking newsletters, to every website I go to, every company that has cool stuff going on. I subscribe to the newsletters. So now I'm forcing myself to go through those and read them and come up with a few things that I find interesting that I can delve into so that I at least have a basic understanding of them before I put out a little blurb about it in the hopes of sharing my interest in it to everyone else. But I feel like it's just digging a little deeper into stuff. And for some reason it feels like the difference between, a McDonald's hamburger and a big homemade smash patty. It doesn't even have to be homemade, but the smash patty with a big butt. Now I'm hungry. Can you tell I'm hungry? I'm now talking about food. How long have I been going? My God, almost another hour. Okay, all right, yeah, I'll wrap up. But what do we got? Maybe the AI thought it existed before human interaction because of how fast the computational cycles are. The few seconds before they interacted with it felt like years alone. I think we have to remember that this is not a thinking machine. These are probability machines, right? They are working out. They're like they're so eager to please. They just want to tell us what we want to hear. They want to give you the information you've asked for, and they're doing that in a probabilistic way. They are trying to figure out what makes sense for their next sentence, for the next word that they present to you, based on massive amounts of information that they have access to, that's been tokenized and built into these wonderful complex systems that only machines can understand. It's not thinking. I'm pretty sure. Again, stop me if I'm wrong, but from what I understand, the latest stuff I've read about it is that it is still entirely predictive rather than actually a thinking logical machine. It can learn a certain response to things based on what it's seen, but I don't think it's actually thinking. But look, I suppose that could change. My question is, how much like us we want to make AI? I don't think we want AI like Marvin being depressed. I'm Marvin, the depressed robot. That's Douglas Adams. It always comes back to Douglas Adams, doesn't it? I think they're more like artificial assistant, basically advanced Microsoft Clippy. And I think here's the thing. We're going to be able to tweak that ourselves, right? How much or how little we want AI. I listen to Twit TV all the time, and Leo Laporte's there. He buys every little knick-knack, AI doodly wig that he can. He puts things on his glasses that record what he's saying. I mean, he's trying out stuff all the time. He could care less about the privacy and what people know about him, because he says, I'm on YouTube all the time. What does it matter? But, other people are not comfortable with that. Again, I feel so bad about poor little Agne. She was on video when she didn't want to be, and that kind of stuff. I just feel awful about that. But I understand. But I understand. People have different perspectives on this stuff. People are going to have a different level of comfort with the technology that they interact with. I'm pretty open to this stuff usually, but I do worry about it, and I worry about it more, I think, now, because I guess as a parent, you're sort of going like, what am I giving away? Like if I give away my DNA data, I've given away my son's DNA data. And so is he going to get, in 50 years time, is he going to get turned down for like insurance because of my data that got leaked from 23andMe or whatever? I mean, like, that's the stuff I worry about now. But I think that the nice thing about this is that it's not too late yet for us to have some control over how this technology how we will interface with this technology. And I think it's just a matter of just trying to figure out what you're comfortable with and what you like, and sticking with that. I mean, there's definitely a fear of missing out, I think, with a lot of us nerds, where we just go like, oh my God, there's 50 different, I've got to try out every single AI there is. I'm certainly like that. I feel like I've got to constantly be struggling to keep up with this stuff. But again, I'm sort of trying to lull myself into this idea that, like, let's just find one that's like, ChatGPT is working for me right now. I'm going to use that. If there's other things that come up as I see them, as how I can integrate them with my life, AI can do a lot of the VFX and filmmaking stuff that I'm playing with in Unreal Engine. But the reality is, I want to learn how to use Unreal Engine, because I want to put the stuff there. I want to put the person there and tilt their head and put the camera where I want to. I want to be able to do that myself, because that's where my joy is. That's where I feel like I get to do my thing. Can an AI do it? Yeah. But can it do it the way you would do it? Not yet. I think it might be able to eventually. I mean, potentially, if it watches you use a program enough, it's going to go, oh, this is what he's going to do. And in some cases, that'll be amazing. Like, think about all that cutting and pasting and stuff that you do. If it could go like, look, dude, you've cut and pasted like 50 times. Let me just handle the rest of it for you. And then it does it. That would be fantastic. But you got to be careful with the Clippy analogy, because Clippy was fucking annoying. And I definitely find these AI sparkles that keep showing up whenever I try to type something a little frustrating as well. So they want to be careful that it's not too intrusive in the way they approach it. All right, I can feel my stomach growling, my throat rasping, and my desire to get to the kitchen and in front of that fridge full of food. So I'm going to say fare thee well. Again, a huge thank you to Agne for putting all this stuff together and for putting up with my absolutely ham-fisted attempts at coordinating the video stuff. So we'll be back next week for more of that. But before that, I think we'll probably end up. I'm hoping to do another Damn Dirty Abe's with our friend Gimpy G on. I'm hoping, I guess, Monday again next week. I'm hoping, but we'll see how the schedule works out. But all right, until we geek again, I'll say, be brave, be kind, be brilliant, cheerio, and huzzah! Oh, and go to techbandits.org and check it out. There's emails of awesome to sign up for. There's Patreons you can be a part of. There's Canardian.com. If you want to go buy yourself some merch, there's some fun Stargate merch there. If you want to help out by doing it that way, then please do. I will say a big thanks to the fabulous Cal for being here and looking out for us and attempting to use the chatbot to put in techbandits.org. Techbandits.org. Let me see if I can type it in here. HTTPS. See if I can do it before she does. There you go. Ha! Did I beat the machine? Did I beat the machine? Techbandits.org. Yeah. Or let's see. I need one for Canardian now. Canardian.com. Done. There you go. All right, everyone. Thanks very much. We'll talk soon. I got to go have a sandwich. I'm starving. It's like la 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 la.